Okay, so here are going to be some examples of using stoichiometry and in a chemical sense. Remember, the balanced chemical equation gives us the mole-to-mole ratio, and that's exactly what we want to do here when we're comparing two things. So first we have aluminum plus iodine gives us aluminum iodide, and we have to ask ourselves, is this reaction balanced? And hopefully we can see that it's not, because the i's are out of balance. So I need to get those in balance, and we can get a 3 here and a 2 here, right? The common multiple between 2 and 3 for I is 6, so we got that, and then that means I have to put a 2 in front of the aluminum. Okay, so we'll start it off nice and easy here, and it says how many moles of I2 are required to react with 0.429 moles of aluminum. So again, we're using dimensional analysis, so we start with the number that's given in the problem, and lucky for us, the number given, or there's only one number given, right? It's just moles of aluminum, so we can assume that we're going to have, or well, actually, the question is asking us how many moles of I2 are required if we want a perfect ratio. So we don't necessarily have excess I2, but we do need to know how much we need. So that's the beauty of the chemical reaction. I don't always have to go from reactant to product. I can go from one reactant to the next. Or if I knew how much product I wanted, I could work backwards to figure out how much of the, I was going to say ingredients, how much of the reactants we need. So it doesn't matter where you go in this reaction. So if I want to use 0.429 moles of aluminum, well, I know that I'm going to get rid of moles of aluminum, and I'm going to get I2 moles of I2 on top. Remember, mole is that idea of it's moles of the molecules of I2, so we use it as a unit. And now I just look at the balanced chemical equation. The number in front of I2 is 3, and the number in front of aluminum is 2. And what that's telling me, for every 2 moles of aluminum that I want to use, I'm going to need 3 moles of I2. Now, could you write this as 1.5 over 1? Yes, but I like to just leave it easy here. The chemical reaction is telling me it's a 3-to-2 ratio. 1.5 to 1 is the same exact thing as a 3-to-2 ratio, but I just set up my conversion factors as is and let the math, and only do the math once instead of having to do the math twice, where I reduce 3 to 2 in my head first and then multiply by 4.29. I just, whatever the chemical reaction says, I go with. So here, 0.429 is how many moles of aluminum I want, and then I'm going to do times 3 divided by 2. So that means I'm going to have to use, or I'm going to need 0.644, if we're thinking about significant figures, moles of I2. And it makes sense, right? If it's a 3-to-2 ratio, I need more I2 than I need aluminum, so this number is bigger, that works. It's a 1.5 to 1 ratio, that works. So there's our answer, right? It was asking for how many moles of I2. Now if we go down here, how many carbon dioxide molecules are produced when 0.75 moles of propane are combusted? Oopsies, so this is a mistake, that should be CO2. Sorry about that. And we have to balance this reaction. So put a 3 in front of the carbon, put a 4 in front of the hydrogen, and now we can look at the oxygens. 6 from the carbon dioxide, right? 3 times 2 is 6, plus 4 is 10, so a 5 goes in front of the oxygen. So make sure you have a balanced equation. Now, again, we're only given one amount, that's good. I know this question is telling us that we are combusting, and we'll learn that that means reacting with oxygen, but we have this many moles of propane, and you might be asking, which one's propane? You know oxygen, you know carbon dioxide, you know water. The propane has to be the C3H8, right? So use your deductive tools, deductive reasoning tools. And when we're looking at this, it's asking us, okay, we know how much of the reactant we're using, so let's go over to product, and I have the balanced equation, so I have the ratio. And remember, the reaction gives us the mole-to-mole ratio. So for every 1 mole of C3H8, we get 3 moles, we produce 3 moles of CO2, and I'm just like, why is it 1 and 3? It's from the balanced equation, right? If we don't have in front, we assume that it's 1. And this doesn't answer the question because I'm not interested in how many moles of CO2, but I'm interested in how many molecules. And remember, we have a conversion that tells us for every 1 mole of CO2, there's Avogadro's number molecules of CO2. Okay. And if we do this, 0.75 times 3, and then we're going to multiply by Avogadro's number, 6.022, times 10 to the 23rd. We get an answer of only 2 significant figures because of 0.75 times 10 to the 24 molecules of CO2. Okay, so once you have moles of something, right, remember Park Street Station of chemistry, you can go anywhere. So in this case, instead of just staying in moles, I'm interested in molecules. Now, understanding that, right, where the balance equation gets us moles, this question here, first of all, we don't have a reaction, so you're going to have to write the reaction. Magnesium chloride reacts with sodium hydroxide to produce magnesium hydroxide and sodium chloride. That's where you're going to get your reaction from, and you have to balance it. And then all of a sudden it says, what mass of sodium hydroxide would be required to produce 16 grams, which is a mass of magnesium hydroxide? So going back to this example that we had with the propane, remember, if we get it to moles, we can use the balanced chemical reaction, right? So if we have a mass of magnesium hydroxide, we have to find a way to turn mass into moles, and hopefully remember that the periodic table provides us that. Remember, when in doubt, mole it out. So if you have a mass, turn it to moles using the mole-to-mole ratio, and then you can, turn it to, if you have a mass, turn it to moles using the periodic table for the molar mass. And once you have it in moles, you can use the mole-to-mole ratio. So I'm going to let you do this question as practice. Okay, so if you can pause the video right here, and you can work on this one yourself, and then you can pull up the video, or pull up the answer key here if you go into OneNote, and you can see the answer and check yourself against the drawn out solution.